A more advanced concept that we learn about in Algebra 2 is how to figure out, based on two events or trends or things happening at once, where they intersect. And we're going to see problems that will allow us to find out where those two intersect or where they come together, and how to solve them in multiple ways. And that's called solving systems of equations. So here's a type of problem that you would see in the real world that can be created into a system of equations and solved using algebra. Kevin had a car wash where he basically, in the car wash, he had 30 cars and 108 tires, and we didn't know how many were motorcycles and how many were just cars. And we could figure it out based on setting up a system of equations. The tables we created in class showed us that if we didn't have the stipulation that there needed to be a certain number of tires, we needed 108, but let's just imagine that we could have any set. We could have 30 cars and 0 motorcycles, so 120 tires. 29 cars and 1 motorcycle. That basically means you're trading a car which has 4 tires with motorcycles which has 2. You're losing 2 tires because you're losing 4 but then gaining 2 back from the motorcycles. So each time you lose a car and gain a motorcycle, you're losing 2 tires in total. And we go down the list until we get to our solution to our problem, which had 2 stipulations. The first was it needed to have 30 cars. The second was it needed to have a certain number of tires. This table represents that you need 108 tires. So 54 motorcycles means you have 54 vehicles in total, and 0 cars. That's 108 tires. 52 motorcycles and 1 car. That's 108 tires. That means I have 53 vehicles. And I'd be working down the table until I got the same as my stipulation, which is 30 vehicles in total. And I come to find out that that means that I have to have 24 cars and 6 motorcycles for that to work. So you can come up with a table, but there are better ways to do it. The first method we're going to learn about is substitution. So we're going to create one equation that represents how many vehicles there are in total, 30. And we're going to create one equation that represents how many tires there are in total, 108. So if x represents cars and y represents motorcycles, this is the first equation. The number of cars plus the number of motorcycles is 30. The second equation represents how many tires there are. Now you need to think and analyze the data a little bit. One car, which is x, is going to give us 4 tires. So you multiply the number of cars by 4. One motorcycle, which is y, has 2 tires. So you need to multiply however many motorcycles you have by 2. So it's going to be 4 times the amount of cars plus 2 times the amount of motorcycles, and that's going to get you 108 in total. When we have these equations, when you can turn them into equations, you can do a lot of good stuff with them. Now in class, I had groups split up into groups of 4, and we basically isolated either of the 4 variables. Either this one, that was one group, isolated that, so it got it by itself, or another group got the y by itself, or another group got this x by itself, another group got this y by itself. So 4 different groups would have seen 4 different things. One group got y equals 30 minus x, that y is isolated. Another group got x equals 30 minus y by subtracting y from each side. This is a more difficult one. Another group subtract 2y from both sides, and then divided each side by 4, and got 27 minus a half x to isolate this variable. And then the last group isolated y on the more complex equation by subtracting 4x on each side, and then dividing each side by 2, and getting y equals 54 minus 2x. Any of these works. One of the tricks is, and one of the mistakes a lot of students make, is where do you put this? If I took this and put it back into this original equation, I would see nothing come out of it. Basically, I'd plug that in. It'd be 30 minus y plus y, and the y's would cancel out, and I'd get 30 equals 30. If I plug this y right here, I'd have x plus 30 minus x, which means the x cancels out, and you get 30 equals 30. You're not going to find anything. So what you have to do is remember to take what you substituted, or what you're substituting and putting into the other equation, the one that you haven't done anything with. So if I solve for x or y on this equation, I'm going to plug it into this equation. If I solve for x or y in this equation, I'm going to plug it into this equation. And we're going to see how that looks in just a second. That's why I say right here into the other equation. I got y equals 30 minus x. I'm going to plug it in for that y. So it's going to be 4x plus 2 times that now equals 108. If I have x equals 30 minus y, I'm going to take that, I'm going to plug it in for x. So that's going to look like this. 4 times 30 minus y plus 2y equals 108. If I start with this, I'm going to plug it into the easier equation. It's going to be 27 minus 1/2 x plus y, or it should be y, sorry. 27 minus 1/2 y plus y equals 30. And the last one is, if I know what y is in my more complex equation, I'm going to plug it into the simple equation. I'm going to x plus 54 minus 2x equals 30. So those are my 4 possible substituted into equations. Now what we got to do is we got to solve these. Distribute the 2, combine like terms, two-step equation. Distribute the 4, combine like terms, two-step equation, solve. If we have the more simple equation where it was x plus y equals 30, there's no distributing because there's no number on the outside, so we're just combining like terms. Negative 1/2 plus 1 is positive 1/2, and then it's a two-step equation. And then finally, same thing, no distributing, combine like terms. X plus 1x minus 2x is negative 1x, and then solve. Negative x is negative 24, x is 24. And no matter which way we chose, we get the same answer for each. Now, once you get 1, the second one is really easy to find. So if I find x, y is easy to find. If I found y, x is easy to find. What I'm going to do is I'm going to plug it into any equation. So let's say I knew what x was. I could plug it into this equation, doesn't matter which one, and I'm going to get 6 because I'm subtract 24 from each side. I could also plug the same thing into the other equation. 4x plus 2y equals 108. If I do that, it's going to be 4 times 24 plus 2y, and it's a two-step equation, and I get 6. Same answer either way. If I knew what y was, I could plug it into the more complex equation. It would be 4x plus 2 times 6 equals 108. 2 times 6 is 12. Subtract 12. Divide by 4, and you get 24. If I plug that into the easy equation, x plus 6 equals 30. Subtract 6 from each side, x is 24. Notice I get the same answer no matter which equation I plug it into. So try this one. By substituting, I want you to solve 4x plus 3y equals 4 and 2x minus y equals 7. Go ahead and pause it and do that now. This may take a while. Oh, and positive answers are possible answers are x is negative 2.5, y is negative 2, x is 2.5, y is 2, x is negative 2.5, y is 2, or x is 2.5 and y is negative 2. Okay, go ahead and pause it. For similar problems, you're going to be on page 126, numbers 1 through 13 odd. So the first way we found was substitution. The second way we're going to find is elimination. In order to do that, the first thing you need to do is have both equations in standard form. So x plus y equals c, x plus by equals c. The good news about this problem is you already have it in standard form. 1x plus 1y equals 30. 1 is a, 1 is b, c is 30. The second one is also in standard form. ax plus by equals c. So we've got it done. If the equations, this is step 2, have matching coefficients, and coefficients are the numbers in front, we would go to step 3. So step 2 is basically a pre-work problem. We need to get some things set up before we can eliminate. If they don't, we have to multiply one or both equations by a scale factor. So here's what a scale factor looks like. Here's our two equations. A coefficient is a number in front of the variable. So 1x and 4x, those aren't the same. 1y and 2y, they're not the same. Either of these need to match. If neither of them do, we got to do this. So we got to multiply one of the equations by a scale factor. So I'm going to multiply the top equation by a scale factor of 2. That's my scale factor. So I distribute the 2. 2x plus 2y equals 60. And I'm going to replace this with this new equation. Because if 1x and 1y is 30, then 2x's and 2y's is 60. So that's going to look like this. Now I've got this equation plus this equation. And now I can eliminate. So what you're going to do is either add or subtract. In this case, I'm going to subtract these two equations to come up with a new equation. And in the process, something's going to get eliminated. 2x minus 4x is negative 2x. 2 minus 2 is 0, and 60 minus 108 is negative 48. So now I've just got negative 2x is negative 48. Now I can solve for this remaining variable. Divide each side by negative 2, and you get 24. Then you have to do what you did in substitution, which is just plug that into one of the original equations. I like this one because it's a lot easier. 24 plus y equals 30, and so y equals 6. So try to solve this by elimination. 3x plus 7y is 15. 5x plus 2y equals negative 4. Possible answers are negative 2, 3, 3, negative 2, 1 half, 4, and 4, 1 half. Go ahead and pause now. For similar problems, you're going to do page 127, numbers 30 through 40 even. Okay, finally, to solve by graphing, the best way to do this, the most accurate way to do this, is to have a graphing utility. There's a lot of great calculating or graphing tools online. Just type in graphing calculator. You can plug in equations into those, and they'll pop up the graphs right there for you. Now, the intersection is what you're looking for. The solution to a system of equations by graphing is where they intersect. So try to solve this one with any method, or I should say any graphing tool. If you have a graphing calculator, plug it in. If you have a computer application online, then type this in. Just know that sometimes you need to write them in slope-intercept form to plug them into a graphing calculator. Possible answers are 1.5 and 1, 3 and 1, 1 and 1.5, and 1 and 3. You're going to want to look at page 118, numbers 1 through 9, for more problems. And that's it. Those are the 3 different ways to solve system of equations. One of the homework assignments that I had students do was solve this problem. So go ahead and pause it and see if you can solve this by elimination, substitution, and by graphing.